Good morning, everybody. Mr. Coy here. It's Thursday, day 4 of our coronavirus freakout. Hope you guys are staying well, taking care of each other, and staying away from your loved ones who are older or with compromised health. Okay, so you guys are doing great. I need to tell you that because you really are. And we're going to keep doing great because that's what we do. So yesterday you guys did a good job with the color coding. I know that in that concept builder, the third part where there's some numbers came into play, it got a little tricky. So I did send out a video last night. If you were stuck on that last part of Concept Builder 3, I think it is, Know Your Potential, please watch that video. It will help you out. So what I'm going to ask of you today, Thursday, is to do 3 things, really. I'm only really going to collect the Concept Builder, but there's 3 things I think you should do if you really want to master this stuff. And here they are. The first thing you should do would be, where is it? This guy. It's just some practice Ohm's Law problems. Shouldn't be too much to it. You're just going to kind of do some really simple problems with this. I'll link this. It'll be available on Canvas shortly. The next thing you should do would be this. It's just more practice with color coding, just to get you thinking about it a little bit. You get into a few more complicated problems, down into this stuff, talking which bulbs are the brightest and all that. I'd like you to give it a shot, see how you do. Obviously, the ones with the biggest drop in voltage will have the brightest light because they're using more of the voltage to push through there. So that's what you're going to do there. And then the last thing I want you to do is you're going to do another concept builder. Um, that's this guy. It's about this concept called equivalent resistance. You can kind of see that in here. Equivalent resistance. So what does that mean? Well, that means if you have a complex circuit, see how here they've got like 3 different resistors. Here's 2 different resistors in one circuit. Oh, these are parallel. These are in series. What do you do? How do you handle it? Well, let me tell you in today's notes. So let me see if I can center this better. Okay, so here we are. So we're at, what's the date? 3/19/20. We're going to talk about equivalent resistance. Now you might be titled, or you might be tempted to call this total resistance, but it's not really that. Because if you say total, it implies that you just add things all up, but we don't add things all up. So sometimes you do, sometimes you don't add them, just add them up. So instead we use the term equivalent, and I'll tell you what that means in a second. Okay, so as we continue moving down here, let's say here's a very simple circuit. Let's say this is 9 volts and this is 3 ohms. All right, so for this thing, for the whole circuit, the total voltage loss is 9 volts. Starts from 9 here, ends up at 0. The total resistance is just this one resistor there, so we're just going to call that 3 ohms. And from that, you can find I, which would be VT over RT, and that's going to be 9 volts over 3 ohms equals 3 amps of current. Big deal. That's not so hard. Anybody can do that, right? But what happens if things get more complicated and it looks like this? Let's say there's, now you've got 2 in series. By the way, these are called series circuits if there's just one path. We'll talk about that in a second. So this is 3 ohms, and this is 3 ohms, and this is still 9 volts. It still has to get from 9 to 0, but now it's going to skip. It's going to lose half of its voltage across this guy, and this will be 4.5 volts. And the deal here is, now you've got a total of these 2 resistors acting together. Now in series, there's only one way the current can flow. You know that, and it's just going to be this. So there's no way for electrons to get from here back to there without going through both of these resistors. You can't skip one. You have to go through each of them to get there. So both resistors act together to make for more resistance. So here we'd say that the resistance total, the total resistance is the 3 ohms plus the other 3 ohms. So the total resistance is 6 ohms. Now, what effect's that going to have on your circuit? Well, remember the total voltage is still 9 volts. That's what you have there. So the total current then is still going to be the total voltage over the total resistance. Now it's 9 volts over 6 ohms, because remember, it's got to get squeezed through 2 of those guys. So now your whole current is cut in half. Remember, when it was just one of those resistors, twice as much current could flow. You can get 3 amps flowing through that because it wasn't too much resistance. Twice as much resistance, you get half the current. All right, you buying that? So this is about in series. So I'm going to back up. Just make sure you know what I'm talking about. All right, so there are 3 basic types of circuits. 1, series. And that is when it's just only one loop. Only one way for electrons to get through there. When you do that, in those, it's like the ones we've been drawing. For these, the total resistance is just the resistance 1 plus resistance 2 plus however many you have. You just add them all up. It's a piece of cake. It's the easiest thing in the world, which might make you think, well, why don't we just call it total resistance instead of equivalent resistance? Well, stick with me, grasshopper. Okay, so the other type, the next type of current, of circuit rather, is called parallel. This is where things get a little bit more complicated. And this is where there's more than one path for current to flow. So let's get into this a little bit. So if I have another power source here, so it's 9 volts, and I have a path that comes down. Now that is just a simple series circuit. Let's say we've got 3 ohms of resistance here. We've seen it, we played with it above, you know what's going to happen there. But now what happens if instead of me sticking another resistor here, we just add up another path going over here? So now the electrons, remember they've got to go from here all the way around to there. But now they can also go this way. They've got 2 paths to travel by now. So think about it. If you get to this and it's backed up and it's slowing you down, if this is a door in a hallway and everybody's standing there for one door and you're waiting for people to get through it, what would you do? Would you stand there and wait if there's another door sitting right there? No, you'd go, you know what? You guys do your thing. I'm moving over here. So that means you get twice as many people flowing at any time because there's 2 paths. So the deal here is that resistance is not just adding them up. Because think about it. If this thing wasn't here, the second one, it was just 1, the total resistance would be 3 ohms. But if you open up a second path, does that make it harder or easier for current to get through this thing? Is it harder or easier for current to get through if it has 2 paths? Well, it's easier. More paths make easier for electrons, also known as charge, to flow. So we have new math here. The total resistance is the inverse of the inverses added up. What? And then you have to flip that. Or a better way to put it is 1 over the total resistance equals 1 over R1 plus 1 over R2 plus dot dot dot. So what's that mean for this guy up here? Well, in this case, RT equals 1 over 3 plus 1 over 3 flipped. Or we could say that 1 over RT equals 1/3 plus 1/3. So these both say the same thing. So what you get from that, 1/3 plus 1/3 equals 2/3. Remember, that's 1 over the resistance total. This is big. I'm going to use this version of it. It's easier. But I don't want to know what 1 over the resistance total is. we go. I don't know, want to know what 1 over it is. So if 1 over it is 2/3, then the resistance total is 3/2. Check it out. Is that bigger or smaller than 3? Hey, it's exactly half of 3. Interesting. So wait a minute. You're telling me if you had something that was like 4 ohms and 4 ohms, these things together act like it's really just one with, is going to be easier or harder to get through than 4 ohms. It's going to be easier. So the whole thing together is like 2 ohms. So this means that 2 4 ohm resistors in parallel are equivalent to 1 2 ohm resistor. So you can draw those 2 4 ohms as 1 2 ohm resistor. Wait, huh? Let's do a couple others. Let's see if I have this. This is 6 ohm. This is also 6 ohm. Then you could draw this whole thing as, what would it be like? Is it more than 6 or less than 6? It's easier to get through if there's 2 paths, so you take the 2 of them together, so it ends up being a 1 3 ohm resistor. This is the equivalent of that. All right, we're going to get hardcore into the numbers later at some point. I don't know if it's going to be tomorrow or we're going to wait till after spring break or what's going on. Still have spring break? What's happening? But for now, I think that you are ready to do the last concept builder, which is right, where is that guy? Which is right at the goats. It's right here. So for which one doesn't belong, we're going to get into this. Let's see if I recognize it. No, not quite. There we go. Looks great. We'll start this. What's going on here? This might be big. Okay, enter. That's fine. All right. Okay. So you just got to figure it out. Which of these don't belong? Well, hey, this is series, so you have 12 and 12 in series. So is it harder with 2 in series or easier? Is this going to be more than 12 or less than 12? Well, it's got to go through 2 doors, so that's harder. So this is like saying it's 24. This is 6. Here's 2 3s together. What's that going to add up to? 6. Oh, so these 2 are the same. So this is the one that's not the same. There you go. All right, so there's enough of that. The second group of problems looks like this. We've got parallel. All right, so which of these 3 has different equivalent resistance than the other 2? All right, so this one's easy. It's just 8 ohms. That's all there is. Here we've got 2 16 that are in parallel. Wait a minute. If there's 2 paths, does that make it harder or easier? Oh, it's easier. So it's going to be more than 16 or less than 16. It's going to be less. Remember, you add these reciprocals up. 1/16 plus 1/16 is 2/16. Flip that over. It's like 8. Hey, this is the same as that. They're both 8. This one, if you add 4, 1/4 and 1/4, that's 2/4. Flip it over. This one comes out to 2. 2 ohms total for this, 8 ohms total for this. So these 2 are the same equivalent resistance, so that's the one that's wrong. Check it. That away. Right, and here's the wizard level. This gets confusing because again, you've got 4 of these. 3 of them have the same resistance, and only 1 of them is different. But now these are parallel, that's parallel. These 2 are series. Yikes. Well, let's do the series first because they're easier. Here you've got 2 ohms and then 6 ohms. They're in the series, so they add up. So this is a total of 8 ohms. Over here, you've got 2 plus 2 plus 4. Hey, that's also 8 ohms. These 2 are the same, which means one of these should end up being 8. Look, that says 8 and that says 8, but remember, what do you do if you have 2 in parallel? You cut them in half. So this is really 4 ohms total, equivalent. 16 and 16, hey, if you have 2 16s, that really means it's a total of 8. So this is 8 ohms, total equivalent. This is 8 ohms, that is also 8 ohms. So that means this is the odd man out. All right, good luck, you guys.